basically because they increase your attack surface. And that could be over doubling the amount of inputs you have. You may extend the application so far that for every input to the application, there's an associated API call for it, and then beyond that, you may have functions that aren't available to regular users that are now available through the API. So maybe a regular user can perform all these functions. Let's say Twitter, for example. Maybe a user can add content and get their content, but if you have API calls, maybe you can see the rate that the person posts, or maybe you can get trends that weren't available through the regular interface. So now you're creating more inputs that then have to be validated and checked. The typical depth of an API is more than a standard user. So the user may have a set of functionality that they have access to, where the API is far beyond that. And if you think about it, a user to access functionality may have to go through like 4, 5, 6 different menus to get to what they're trying to do. Like say for instance they were going to send a message to somebody. They would have to log into the application. They would have to go to the messages menu. They would have to hit compose. They would have to add their data, and then they would have to hit send. Well, add a data, add a recipient, and then hit send. Whereas an API call, it might be one call. So now you have all of this functionality in one specific location, very easy to consume. And as you might imagine, if you have more expanded functionality, you also have elevated privileges. So you need to have elevated privileges to consume these extra sources. And what comes along with elevated privileges is higher trust levels. So now your API is operating at a higher... I love that picture too, by the way. I mean, who wouldn't want the king hitting on them, right? So you have higher trust levels. So as going back to people making assumptions about content that are coming into the application, those assumptions are assumptions at a higher trust level because it's seen that applications and other developers are consuming resources and not users. However, they're not thinking about the things that are leaked to a user through just standard calls. So there is some good news to all this, and it's that people are using standard protocols and data formats when they're creating their APIs. So there's not a lot of reinventing the wheel from that perspective, which is good because some of these things we've kind of already fleshed out. Like data formats is probably not, we probably don't need to use some weird binary format that we created ourselves when connecting to these things. So there's less vulnerabilities from a reinvention perspective, so you don't have to worry about things at that much lower level. And they're also readable and understandable. So if you don't know what JSON looks like, it's very easy to find out what that is from a couple of searches. And it also means your standard common tools can be used to analyze API calls. So you can use your standard Wireshark, Burp, WebScarab, whatever you want to analyze these. So what I kind of came up with for API testing was a simple little method to go through and identify the presence, the purpose of the API, the structure of the calls, and then of course violate those structures and then evaluate the results. So most of the rest of the presentation deals with either identifying the purpose and structure and of course the fun part, which is violating that purpose and structure. You basically have two methods for identifying APIs, as you might imagine. There's zero knowledge and documented. So zero knowledge would be for kind of internal APIs, and documented is pretty self-explanatory. And since I didn't want to put anything else on this slide, I just figured I'd add that in there. Ninjas are everywhere. And since APIs are meant for consumption, most often there are documentation laying out there somewhere, even if it's not meant for you to see. Because we all know that people only put appropriate things on websites, right? Like nobody would ever put documents to default passwords for ATMs or anything like that on their corporate website. So you might be surprised when going through and doing testing, you might run into documentation for APIs that aren't published publicly. And that can be a win for everybody. Well, if you're the testing team, it'd be a win for you. So you can search for applications using search engines, pretty obvious. So if you didn't know Twitter had an API from just Googling for Twitter API, you might notice that, hey, well, I use a Twitter application on my phone, or I use a Twitter application on my desktop. So it's probably making some form of calls to an API. You can also check the site, because people are very happy when people create applications that interface with them. And you can use tools, because it might not be obvious that you have a widget or something installed in your web browser that is making calls to an API. So I wouldn't know that most people that install, say, social network applications, I would say that most of them wouldn't know that they're making some sort of backend API call. But you can see those if if you're doing a inspection proxy in your browser, like you'll see those calls going out. And from a zero knowledge perspective, most of the reason why those aren't published is because they're for internal use only. So maybe, like say Hulu, for instance, maybe they only want to create a desktop application that they can use, and they don't want to open it up to everybody. Or maybe they want to have some sort of developer vetting process, so not just anybody can create an application that interfaces with their service. Because sometimes that kind of makes sense, because you have people creating like crappy applications that then make your service look crappy. So that kind of makes sense. And documented is where you get obviously full win. And that's typically the case, because people put this stuff out there. So, because the larger user base, the more popular your application becomes. And that's really what it's come down to. Everything nowadays is integrating with something else. There's not a lot of static websites left out there. So it's all about a functionality arms race between you and your competitors. So that's pretty much what it's come down to. And what you also get with not only identifying that, one, there is an API there, and two, structure data, you also get architecture information and capabilities of the API. So when you're going through looking at the API and you're doing kind of this functional review, and you're trying to determine, hey, I want to know what this thing does and how it does it, you basically have that all documented there, your capabilities and the depth of the API into the application. One of the things that Google came out with was Open Social, and it was originally meant as an API for social networks, and then they decided that, hey, this is a great idea. It's not only for social networks anymore, anybody can use this API. There are some people that think that, wow, all of this functionality I get with this API just isn't enough, I need more, so they'll end up extending the API even further. So those are things that you would find with documentation as well. So even if you recognize that somebody was implementing Open Social because maybe you saw some Google-oriented type code in there, just be aware that they may have extended it even further. So it might go even deeper into the application, be way worse than you thought on the surface. Because when you implement somebody's third-party API, you're swallowing up all this functionality that they originally intended, which you may not even need. And typically, it's the kitchen sink up front, and then you just kind of take off what you don't need. And in that case, you may be allowing people to make calls to things that you never intended them to make calls to. So you get that, you get the extended API documentation, and you also get case information. So not only would it tell you how to do something, it would probably tell you why to do something. So in this case, you would want to do this. One other type of API that would be hard to identify without any documentation would be server-to-server APIs. So if you kind of have something in place where content from another server is being called and placed onto another server, there's no client-side interaction with that. So from a testing perspective or from a user perspective, you would never see the data going back and forth between servers, because none of that is like leaked to your web browser or your client that you're using. And also with documentation, you get some win from modules that make calls to the API.
So what about latencies for server-to-server communication? Are there going to be a lot of things you can deduce from timing to be able to tell whether or not you're actually having back-end calls?
Whether it's making back-end calls, you could. But as far as like structure and how it's happening or what the calls look like, the question was, what about latency for back-end calls? Would you be able to deduce that something is making a call there? It would depend on the site too, because maybe you're used to it being horribly slow. But it would really be hard to identify the call and what the call looked like without any kind of documentation.
A good example would be Amazon. I know for a fact they, when you pull up their main page, they make about 250 back-end calls.
Yes.